Welcome to the deep dive. Today, we're putting on our safety vests and plunging right into the pretty intricate world of modern logistics, specifically the warehouse floor. If you think about it, if you track any fast-moving consumer good, from the factory to your front porch,
Yeah.
that whole journey is defined by one thing, and that's the efficiency of these massive storage and fulfillment centers that handle all the traffic.
And that efficiency is under just tremendous pressure. I mean, the modern logistics network, it demands not just speed, but resilience
Yeah.
and immediate adaptability. The complexity today, it's just off the charts. You've got different inventory sizes, temperature controls, fluctuating global demand. It all means the old way of planning a warehouse layout, which was often a multi-month static manual process. It's just hopelessly inefficient now.
It's completely broken.
It locks companies into designs that are obsolete almost the second they're finished.
Exactly. You plan for today, and then 6 months later, you have new product lines, different order volumes, and the whole system just grinds to a halt. So our mission today is to cut through that gridlock. We want to understand how generative AI, Gen AI, is fundamentally revolutionizing this core industry challenge. How it's enabling companies to create smarter, faster, and much more adaptable physical spaces.
And this is so key. When we talk about Gen AI in this context, in warehouse design, we're not talking about simple process optimization.
Okay.
We need to be really clear about that distinction. Gen AI is a class of machine learning that doesn't just analyze an existing system to find, say, the best route.
Yeah.
It actually creates new data and novel design solutions based on the patterns and constraints it observes.
Okay, let's dial in on that, on the novelty. Because if a traditional optimization algorithm can already find the most efficient travel path in a facility, what unique capability does Gen AI bring that lets it generate a truly novel layout?
So the crucial distinction is that traditional methods, think of something like linear programming, they optimize a predefined system. They work within the constraints you give them. Aisle 1 is 10 feet wide. Here are the shelves. Now find me the fastest route.
Got it.
Gen AI, on the other hand, it's a creative tool. If you give it operational goals like minimize travel time by 30% or maximize storage density, it designs the entire structure itself. It proposes layouts that a human or even traditional modeling might never, ever conceive of.
So things like nonlinear flow patterns.
Yeah.
Or different kinds of storage geometries that break that old rectangular grid.
Exactly that.
So it's not just optimizing the vehicle, it's building a new, better road network entirely.
Precisely. It's designing the track to fit the race.
That brings us to the foundation of this whole revolution, which has to be the data. What kind of raw material is this Gen AI actually feeding on to generate these complex, ingenious designs?
Well, the foundation is absolutely this comprehensive data-driven design. The AI system processes just vast amounts of historical and real-time operational data.
And we're
talking about item dimensions, required storage environments, precise operational heat maps of existing traffic flow, and crucially, very detailed analytics on inventory characteristics.
Okay, so let's skip the basic definition of picking frequency and jump right to the application. For our listeners, how does Gen AI leverage the complexity of that item velocity data in a way that traditional planning methods just couldn't?
That's where the analysis gets really deep. It's not just about how often an item is retrieved. Gen AI analyzes the co-picking relationships, meaning which 5 items are always on the same truck or often appear in the same order. By identifying those patterns, that proximity requirement, the AI can propose clusters that ensure those frequently grouped items are placed right next to each other.
Which is crucial for maximizing throughput, I assume.
Absolutely. It also integrates data on what's called cube utilization, making sure every available cubic inch of space is used efficiently, not just the square footage on the floor.
That level of detail, integrating velocity with spatial adjacency, that's just incredibly powerful. But a blueprint is useless unless you know it's going to work under, real-world pressure. So how does Gen AI even handle the testing phase before a single shelf gets moved?
Right, and that's exactly where simulation and rapid iteration really take center stage. This is where Gen AI truly justifies its name. It runs these dynamic simulations of the proposed layouts, evaluating their performance against very specific operational KPIs.
When you say dynamic, what are these simulations modeling that's different from, say, a simple fixed variable test?
They model uncertainty. That's the key. Traditional modeling often assumes these perfect static conditions.
The ideal scenario.
The ideal scenario, yes.
Yeah.
Gen AI uses techniques like stochastic modeling and multi-agent systems to mimic the real messy world. So the simulations don't just calculate average travel time. They account for things like a sudden spike in order volume from an unexpected sale.
Or seasonal shifts.
Seasonal inventory shifts, exactly. Or even the momentary unavailability of a specific machine or human worker because of delay.
So it's testing the design's resilience to chaos, not just its efficiency in ideal conditions. That feels absolutely essential for modern logistics.
It is. And furthermore, it incorporates the interaction between different agents, robots, forklifts, human pickers, and assesses how their conflicting paths might impact the overall flow. This rapid iterative testing allows Gen AI to cycle through hundreds, maybe even thousands, of potential layout permutations in a matter of hours. It identifies the configuration that maintains the highest throughput and the lowest operational cost, even under stress.
That transition from a theoretical design to a performance-tested, stress-resistant layout, all done digitally before you spend any capital, that's a complete game changer for managing risk.
It minimizes the very, very costly risk of making physical remodeling mistakes.
Okay, so let's talk about the tangible results. We've moved from the planning screen to the actual physical space. What does this deep optimization mean on the warehouse floor? I mean, in terms of space optimization.
Space optimization is where the AI's creativity becomes, visible. Gen AI fine-tunes physical factors down to the millimeter. It optimizes precise aisle widths, not just based on vehicle clearance, but on traffic density projections.
I see.
It determines the ideal shelf heights, the stacking methods, all tailored for specific inventory profiles and how they're retrieved.
So the warehouse floor stops being this rigid grid and starts behaving more like a fluid optimized landscape based on how products actually move.
Absolutely. The optimization maximizes cube utilization. A traditional layout might prioritize standardizing the aisle size just for simplicity, but that sacrifices efficiency.
Sure.
Gen AI might propose wider aisles and zones with high congestion and high velocity picking, while at the same time suggesting narrow, high-density storage for slow-moving inventory that only needs occasional access.
And what's the direct measurable benefit of that level of spatial micromanagement?
The benefits compound immediately. By streamlining the flow and ensuring that the high-demand products require the least travel distance, you drastically reduce congestion points.
Those bottlenecks.
Those frustrating bottlenecks that waste hours every day. This tangibly improves worker efficiency because they're spending less time walking and searching. We see a significant streamlining of the entire material handling process, which translates directly to time savings and therefore cost reduction. A smarter space is just inherently a more efficient and a safer space.
Okay, so let's unpack the managerial implications of this shift. We've talked about the physical space, but how does Gen AI fundamentally change the decision-making process for warehouse leaders, people who have traditionally relied on, years of deep, accumulated operational expertise?
It changes decision-making by institutionalizing a data-driven approach. Warehouse managers move away from relying on intuition or heuristics or just replicating past designs.
This is how we've always done it.
Right. Instead, they favor objective, quantifiable metrics. Every proposed layout doesn't just look different, it comes with its own projected performance dashboard.
But isn't relying purely on historical data a bit risky? I mean, intuition often accounts for future market shifts or external factors that a data model might miss. How does Gen AI address that risk of being too heavily reliant on the past?
That's a really sharp question. And the AI combats this by running simulations based on projected future order profiles, not just historical ones.
Ah, okay.
So the manager can input hypothetical scenarios, let's say a 50% spike in a specific product category, and the AI assesses how the layout handles that stress test. The objective metrics they review include things like pick-to-ship cycle time, stock replenishment efficiency, and overall inventory turnover rates, all projected over various market conditions.
So it's about scenario planning, not just reflection. That makes the shift less about replacing human knowledge and more about augmenting it with some serious predictive power. And what's fascinating here is the validation that Gen AI provides. It offers decision makers confidence that their substantial capital investment will actually pay off based on quantified future performance.
And that confidence is crucial because modern supply chains, they demand not just efficiency today, but incredible scalability and flexibility for tomorrow. Businesses are constantly growing, order volumes fluctuate wildly, inventory is always changing.
Yeah.
How does Gen AI keep that optimized layout from becoming obsolete in 6 months?
Yeah, the whole concept of a static blueprint seems totally antithetical to modern market dynamics. How does the AI turn design into a continuous live process?
GenAI's greatest strategic advantage is its continuous adaptability. It doesn't just output a final fixed blueprint, it initiates an ongoing optimization loop. As real-time data flows in, new inventory types are introduced, order volumes shift, or new tech like automated guided vehicles are integrated. The AI continuously evaluates the current layout against the goals and suggests real-time, micro-level modifications.
So the warehouse floor plan is essentially a live document, subject to constant data-driven evolution.
Precisely. And if we connect this to the bigger picture, this flexibility is what ensures long-term efficiency and scalability. The system can even be designed to automatically trigger alerts if a specific flow metric drops below a threshold. It identifies the bottleneck and suggests the spatial adjustment required to fix it.
Whether that means widening a temporary path or just relocating a cluster of stock.
Exactly. This capability ensures that efficiency endures as the operational needs evolve.
This has been an incredibly deep and very clear view of how generative AI is conquering a massive logistical challenge. So to summarize the overarching impact here, Gen AI allows for these rapid, data-driven, iterative design processes. It moves warehouse planning from a static, expensive headache to a continuous, optimized adaptation loop that saves time, money, and minimizes operational risk.
That is the perfect encapsulation.
Yeah.
Gen AI is poised to become an essential, I'd say indispensable tool in logistics, leading to not just smarter but more resilient and sustainable warehouse operations globally.
Right.
And the benefits they cascade through the entire supply chain, which means faster deliveries, reduced costs, and overall just better service for everyone.
What a compelling application of cutting-edge technology in such a physical, foundational industry. And here's a final provocative thought for you to chew on, drawing on this continuous optimization we've discussed. If Gen AI can continuously optimize a complex physical structure, like a warehouse floor, in response to changing data and demand in real time, what traditional static planning process in your professional life might be next in line for this kind of continuous data-driven reinvention? Think about the annual budget plans, the fixed marketing strategies, or the rigid organizational charts that so often rely on old blueprints. What could they look like if they were allowed to evolve daily, driven by live performance data?
It really challenges the very definition of a finished plan.
Indeed. We'll see you next time on The Deep Dive.